No. It wouldn't.
Think about
You don't even have hair. You don't have the texture. Not for it.
All right.
Like that. Purpose will make it.
Oh yeah.
Stop talking.
Dude, I can see that. Dude, I could growl and it would be normal. If I have household grade. Just such an Asian haircut, bro.
All right, ladies and gentlemen. All right. Take out your packet, ladies and gentlemen. Get to number 10 on the first worksheet within your packet.
And then the second one. Because I did 2014.
All right. So here we go, ladies and gentlemen. Hey. Give me your attention. You'll get some time to work, okay? And then we have to get through some things today. But we'll get through them a lot quicker if you will give me your attention and listen. What mass of aluminum nitrate is produced when aluminum metal reacts with 41.6 grams of aluminum nitrate in a single replacement reaction? All right. So aluminum metal is a reactant. Plus lead 2 nitrate, PbNO3, 2. Now again, if you're wondering where I get lead nitrate from, lead is a +2 charge because of the 2 right here. Nitrate is an NO3 charge that has a -1, so I need 2 of the NO3 groups to balance off the lead. This is going to be aqueous because it is a single replacement reaction. Produces. Lead and aluminum are going to change places. So lead will be the lone element here, and aluminum nitrate will be the other one. Again, aluminum, though, now, ladies and gentlemen, has a +3 charge. Nitrate still has a -1 charge. So that means there are going to be 3 of them. The compound will be aqueous. Questions on this, ladies and gentlemen? So now I balance off my chemical reaction. PbAlNO3. 1 lead, 1 aluminum, 2 nitrates. 1 lead, 1 aluminum, 3 nitrates. So therefore, I'm going to have to put a 3 in front over here to get to 6. That changes this to 3. I'm going to have to put a 2 in front over here to get to 6. That makes this a 2. 2 in front here will handle that. A 3 in front here will handle this. Questions, ladies and gentlemen? Okay. Now, we are given 41.6 grams of lead nitrate. We are asked to find out how much aluminum nitrate is created, okay? The mass of it, all right? So take what you're given. And get it into moles. To get it into moles, we use 1 mole on the top. On the bottom, 207.2 plus 28.02. This is PbNO3, 2. And 6 times 16 is 96.0. So we're looking at 0.22. 1, carry the 2. That means that's 13, carry the 1. 331.22 grams of PbNO3. Again, I am not grading you on the units here, but this should say mole on top and grams on the bottom. You do not have to put the substance. Questions, ladies and gentlemen? Okay, so now after we have done that, ladies and gentlemen, we are going to do our ratio step. Our ratio step is what we're going into compared to what we are in. So our ratio step is 2 moles of aluminum nitrate over 3 moles of lead nitrate. Okay, so that is step 2 of the process. Rose. For what? For something else. Okay.
Probably that college checking meeting that I had.
Okay. Normally they send passes for that, but okay, we'll figure it out as we go. All right. So then, ladies and gentlemen, we have taken what we've given, we've gotten it into moles. We have used our molar ratio step. What is the third and final step of our problem?
Put it into grams.
Put it into grams. Report out in the unit that they are asking you. So I'm going to use formula mass to get it out into grams. But my formula mass this time, ladies and gentlemen, is for AlNO3, 3. So that means aluminum is 26.98 plus 42.03 plus 144.0. Okay. Again, if you're wondering where this came from, this is the 1 aluminum, this is the 3 nitrogens, this is the 9 oxygens. Add this up, that is 0, 1, carry the 1, that is 3, carry the 1, that is 1, carry the 1, that is 213.01. That goes on the top, ladies and gentlemen. There we go. Okay. So now I need someone to please take their calculator, do 41.6 times 2 times 213.01 divided by parenthesis 331.22 times 3, close the parenthesis and hit equals.
I got 17.8, but I did it like step by step.
Okay.
So that's what I got.
That's fine. Again, we can do the math differently as long as you're doing it correctly. So if you do 41.6 divided by 331.22 times 2 divided by 3 times 213. I don't care as long as we're getting the correct number.
No, I just did
And
it.
this is grams of AlNO3, 3. Questions on that portion? Okay. Now, there is a way to measure how well you've done an experiment. And that, ladies and gentlemen, is called the percent yield. Okay. percent yield is a simple formula. The formula for percent yield is it is equal to the experimental value and I will write that out for you.
Is this gonna be on our quiz on Friday?
Nope. And this has to be given in the problem, because you didn't actually do the experiment. Okay? This is this 15.2 grams up here. That is the experimental value. It says you actually got this much. Okay? And you take the experimental value and you divide it by the accepted value. The accepted value is your calculation. Your calculation right here, ladies and gentlemen, this number right here is how much you should have gotten. That is the accepted value. That's how much you should have gotten. Now, maybe you didn't. Maybe something went wrong in your experiment. Maybe you lost some sample somewhere. Whatever. Okay? But we would like our percent yields to be numbers that are very what? What would be perfect? 100%. Okay? By the way, I didn't show it. I will try to add it into here for you. Because you are taking what should normally be a smaller number divided by a larger number, you take this times 100 because we're calculating a percentage. Anytime we're doing that, we do times 100. So our percent yield is equal to the 15.2 grams in the problem up above divided by the 17.8 grams times 100. Can somebody take and do that math for me real quickly?
I got 85.4. Yeah, I got 85.4.
We're good? Okay. Now, remember when we did percent error? Percent error is the same kind of calculation, except percent error, you're saying, all right, how much were you off by? That we want to be a low number. This is percent yield. How good did you do at collecting all the information? We want it to be a high number. A percent yield of 85.4 would be a percent error of 14.6. Okay? So it's just two different ways of looking at it. Okay? And it's just a little extra thing that I have you do. I'm not going to have you do it on the quiz. I'm not going to have you do it on the test. We will do it on the lab that we do for this unit when we do our lab. I was going to do it tomorrow, but we're not going to be ready for it tomorrow. So probably next week, Monday, we're going to do the lab. Okay? The quiz is this Friday. Quiz will have a problem similar to this on it, or one of the molarity problems, or one of the volume problems with PV equals nRT. Actually, it's two problems. Okay.
On the board, you have the arrow. Does that mean like we're going from those to those?
These are the ways you will get in. These are the two ways that I will have you go out. I will not have you do molarity yet. Okay? So you made this problem, we started out with mass, we ended up with mass. The other day we were doing ones where we started with volume or molarity and we ended with mass. Sometimes we ended with the volume of a gas. That's what will be on your quiz.
Wait, so then the percent yield's not going to be on our
No,
official
it is not. It is not. Okay? Questions? All right. You've got till 10 o'clock, ladies and gentlemen, to work on any problems in the packets you want, to going back and work on them at the lab stations, whatever. At 10 o'clock, we start talking about limiting reagents. Questions? Okay, let's go to work. Let's get some things done, ladies and gentlemen. Sure.
It's up there. Mass, volume, and molarity.
nothing going on in them.
You can skip that part though.
I know you
You know how to
can't.
use technology. Do you?
No, I just make the videos. So please remember, when you have a compound, magnesium, it is a +2. A polyatomic, something that ends in ATE. Let's use borate. Somebody tell me what borate is on the back of your periodic table.
BR.
No!
Borate.
Borate. ATE ending means turn your periodic. BO3 -3? All right, so now we've got to do that crisscross method. Mg3, BO3, 2. Now again, if you're good at writing compounds and you know the charges and you can do this in your head, I don't care. But if you don't, you need to write it out. And you can't just be guessing. Well, I think it's a +1. I think it's a -2. You got to know, because if you don't, ladies and gentlemen, it's going to lead you to problems later on. Okay? The other thing is, please remember, if you're talking about a lone element, if it's one of the 7 diatomics, you have to put a 2 by it. Otherwise, it's probably not going to balance somewhere else down the line. Okay? So, let's take a look at this, ladies and gentlemen. Now, here is the good and the bad news of a limiting reactant problem. The good news is you already know how to do them. The bad news is it's a little bit more work. Okay? Because now, instead of telling you that one thing is in excess, when something is in excess, that means you will not run out of it. That is what excess means. There's some left over. Well, in a chemical reaction stops when you run out of something. And once it stops, you can't make any more. Okay? So, again, what we have to do now is do the same process twice. Take what you're given, get it into moles, use the molar ratio step. Okay? But we're going to stop after that step in these problems temporarily, and I will explain why. So, slide number 24 is where I'm going to, ladies and gentlemen. Here is your question. Ammonia, NH3. I give you this. Why? You would not know how to write the formula for this otherwise.
Is that not on the periodic table?
No, it is not.
On the back.
NH4, ammonium is. Thank you. Ammonia is not. Okay? No, it's not your bad. You recognized it, but it's slightly different. And again, IA versus IUM, slight spelling difference, big difference in formula. Is the most common chemical produced in the United States. It is used to make fertilizer and other products. Ammonia is produced in a synthesis reaction between nitrogen gas and hydrogen gas. And if you have 1.5 times 10 to the third grams of nitrogen gas and 1.5 times 10 to the third grams of hydrogen gas, which is the limiting reactant and how many grams of ammonia is produced? Okay, so let's go back. A synthesis reaction is one where there is only one product, and this is your product. Nitrogen gas is N2, hydrogen gas is H2. To balance this off, ladies and gentlemen, I end up with, to start, I would have had this. 2 of these and 2 of these. Over here, I had 3 of these and 1 of these. So, again, I have to get the hydrogens to 6 because that is the least common multiple of 3 and 2. So I put the 3 up front here, that makes 6 of these. I put the 2 up front here, that makes 6 of these. But it also makes 2 of the nitrogen, so everything works out. Questions?
This isn't on our quiz on Friday, right?
A problem like this is possible because this is a mass to mass reaction. Okay? This is a mass to mass. Not the limiting reactant part, but the mass to mass part. All right. So next, ladies and gentlemen, I have a balanced chemical equation. Now, I'm going to take what I'm given, and by the way, I guess I didn't put it on here. I should have. If the number in scientific notation bothers you, take it out. 1.50 times 10 to the third means you take 1.50 times 10 3 times. Which means you're sliding your decimal 3 places. 1500 grams of nitrogen is how much I begin with. I'm going to begin with the same amount of hydrogen gas. And the question that I'm looking for is how much of this am I going to produce in grams? Identifying what I'm given, identifying what I'm looking for. Questions? So now, 3-step process. Number 1, take what you're given and... So I'm going to start with the nitrogen. I'm going to take what I'm given and I'm going to get it into moles. Now this is 28.02 because the formula is N2. Nitrogen is 14.01 times 2 of them, 28.02. Next, I'm going to do my ratio step where I'm going to compare nitrogen to ammonia. 2 moles of ammonia on top, 1 mole of nitrogen on the bottom. Now, I am not going to go to grams yet. You'll see why in a minute. But I have to at least get through the ratio step. Questions? So I find out how many moles of ammonium I will create. Now I'm going to take the grams of hydrogen gas. And I'm going to do the same thing I just did. I'm going to take what I'm given and I'm going to get it into... I was hoping for a little more enthusiasm. Moles. 1 mole over 2.02 grams. Then what? The ratio step. But now, still 2 moles of ammonia over 3 moles of hydrogen. Now, you remember before when I said you don't want to put these here, you don't have to? Here, they are helpful so that I know what I am talking about. Stop the reaction there.
So we're doing.
Go ahead.
Like we're doing the this like what we've been doing.
Correct.
Like mass to mass or whatever.
For both.
But yeah, for both of them.
Yep.
And then for the same like product.
Well, we're going to the same
Like,
product.
We're going to the same one.
We're going to the same product, yes. Okay? So, this amount of nitrogen would allow us to make 107 moles of ammonia. This amount of hydrogen would allow us to make 495 moles of ammonia. Which one of these two can you make? Nope. Only the smaller one. Why?
Wait, can you say that?
Oh wait, that's H, right?
You've got these 2 amounts that you could possibly make.
Mm-hmm.
You can only always make the smaller amount. Because then you're out of this. And the reaction stops.
Wait, so if we're doing this and we get 2 different amounts, one's
You're
larger,
going
one's
to
smaller,
get 2 different amounts.
we always go use the smaller amount?
Yes.
And that's our answer?
No, because we're not done yet.
Oh.
Okay?
And
2
then
things.
We use that one to finish and get like
This
the
is
grams
now the
produced.
one that we're going to take and we're going to convert into grams.
Why can't we just do both of them?
Well, you could. And you would find out that this amount of grams would be smaller than this one. And that would be not bad in this problem. But stop for a second and imagine having to put this into PV equals nRT and then have to put this into PV equals nRT. You would always find a smaller amount. I'm just trying to save you some work. Okay? And again, going into formula mass wouldn't be that hard with either one of these. And you would get a smaller amount here than you would get here. I'm just having to save you from doing that calculation twice. You don't have to. You still have to do it though. So we are going to take, this is the smaller amount. Now, please listen to this carefully. The limiting reactant is what made that smaller amount. A reactant has to be the limiting reactant. I have people who by this will put limiting reactant. No, that's not a reactant.
The N2.
That's a product. But what created that is the limiting reactant. Okay? So in your problems, you get 2 points for saying which one was limited. Now again, on your problem, you could simply do this. Above the one that is limiting in the reaction, I will understand what that means. You've told me that that is the limiting reactant. You can put N2, limiting reactant. I will understand that. What I will not understand is if you do this. That is not a limiting reactant. Okay? So you've got to go back and tell me which one. So now, again, I'm not saying that you have to put N2 here and H2 here and N2 here and N2 here. But you better dang sure you know which one you're talking about here so that you can tell me which one is the limiting reactant. Do you understand what I mean? So now we've identified the limiting reactant. Now the last step, take that 107 moles, convert it into mass. Formula mass. Boom. There's your answer. There's your answer. Okay, KP, you're looking at me like I'm crazy.
No. Sorry, never mind.
Sig figs? Or what?
No. I get it now. It just took me a second because,
Okay.
yeah.
No, that's fine. But again, if you're looking at me going, man, that worked out to be exactly 20. No, it didn't. It might have been 19. It might have been 21. I rounded it because how many sig figs? 3 here, 3 here. You got to be in 3 sig figs. Okay, you got to be in 3 sig figs. Now, here's the good news. I didn't introduce you to anything new other than the fact that you have to do it twice. You're still doing the same exact steps you've been doing. Take what you're given, get it into moles. Use the molar ratio. Here's where the molar ratio is critical, though, people. If you stop here, you may not get the right answer. Why? You're getting 2 of these for every 1 of these. Here, you're getting 2 of these for every 3 of these. That ratio makes a big difference in how much product is created. Stop after the ratio step. Okay? Questions?
I just want to confirm for molar ratio, it's what we have on the bottom and what we're going to on the top.
Correct.
Okay.
So both of these ratios here will have the same thing on the top. You're going to the same thing. So whatever is on the top in this ratio will be on the top in this ratio. But what will be different are the 2 bottoms. Questions? Now, if you think that I am mean, ladies and gentlemen, you're right, I used to be, and I used to be very mean. And when Mr. Arts was here, we wrote problems where these numbers,
Are the exact same.
no, but really close. And if you did rounding, guess what? You didn't find the limiting reactant.
Oh, that's good.
I don't do that anymore.
You sure?
What?
You sure?
Well, here's the thing. Let me rephrase. Some of the problems are written by the computer, and depending on the numbers they pick, it may come out to be close. It may come out to be close.
What if it's the same?
Then they're both limiting. You could pick either one.
Oh, he's got to get the same answer again.
If you get the same, that's a great question. If you get the same amount produced, they're both limiting, but you could pick either one amount and figure it out. Okay? Okay? Questions? Very good. Okay, so now we got a molarity. 212 milliliters of 4.25 molar magnesium sulfide is mixed with 194 milliliters of 2.99 molar aluminum chlorate. How many grams of precipitate will form? Very common question that you'll probably see twice on your test. Balanced chemical reaction. Magnesium sulfide. Mg is a +2, sulfur is a -2. This is done. Aluminum chlorate. Aluminum is a +3, chlorate is a -1. That's why the 3 is out here. Double replacement reaction. These are both aqueous. Double replacement reaction. The metal here and the metal here change places. So we get magnesium chlorate. Magnesium's a +2, chlorate's a -1. That's why the 2 is here. Aluminum is a +3, sulfur is a -2. That is why the 2 and the 3 here. And this, ladies and gentlemen, is where you have to use the back of your your second sheet. This one. Now, here's the one thing I know. Chlorate never precipitates. Never. It's up at the top. Automatically aqueous. So I got to check sulfur. Sulfur is normally a precipitate, unless it happens to be with a cation of group 1 or 2. Cations of group 1 or 2 are the first two families on the periodic table. Those are the cations of group 1 and 2. Aluminum is not in there. So this is what precipitates, ladies and gentlemen. If nothing precipitates, you write down no reaction and you're done. You think I'm going to make a 20-point problem on your test that you write no reaction?
No.
No. Okay? So you need to find the one that precipitates. Okay? Now, what am I given? 212 milliliters of this at 4.25 molar, 194 milliliters of this at 2.99 molar, and I'm looking for grams of that. By the way, I balanced the equation. Does anyone have any questions on that? Do you want to see how I did it? We're good? Okay. So now, doesn't matter which of these you start with, ladies and gentlemen. You have to do them both. So if you wrote this and this order was switched around on your test, that's fine. Absolutely. If the products are switched around in their order on your test, that is fine. As long as these two things are after the arrow and these two things are before it, we are good. Questions? By the way, aqueous, 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 solid. Always the way it'll be in a double replacement reaction. Okay? Actually, you might find water created. Water is another sign of a double replacement reaction. Okay?
So either be 3 aqueous in a solid or 3 aqueous in a water?
Yes, possibly. Possibly. Very.
Wouldn't the water be aqueous too then?
No, because
Or it will be
aqueous means
gas.
dissolved in water.
Oh, water can't.
Water would just be a liquid. Water cannot dissolve itself in water. Yes, good catch. Molarity.
Yeah, correct.
Take the milliliters, convert them into liters.
But when you're multiplying
Times the molarity. 4.25 molar is 4.25 moles of magnesium sulfide in 1 liter.
Wait,
Stop. Shoot.
how is sulfur a precipitate if sulfur is only dissolved with water with cations?
You're reading the exceptions. That bottom part of this chart,
Oh, because it says so.
it normally will be a precipitate unless it happens to be with one of those exceptions.
Right, but
It's not with one of those exceptions, Cynthia.
So with these ones, with NH4 and
And it
group 1 and 2, it'll be aqueous, but it'll be solid if it's with the
so if
other
it's not with the
ones.
solids that precipitate.
Yeah, it says here are solids. It says it will form a precipitate.
So any substance with AL it does, right?
Well, if it's with aluminum, if it's with cobalt, if it's with copper, if it's with zinc, those are all not in group 1 or 2.
Yeah, with anything except for these first 2 rows.
Okay? So that middle table, remember, normally it's going to be aqueous unless it's with an exception. The bottom table, normally it's a precipitate unless it's with an exception, then it's aqueous. Okay? So, liters times molarity times the ratio step gives us the moles of aluminum sulfide. Notice 1 to 3. 1 over there, 3 over here. Do the same thing for our second reactant. Take the milliliters into liters times the molarity times the ratio. Ratio makes a big difference here. This is 1 to 3. This is 1 to 2. Okay, we get 0.2900. Which of those two amounts can you make? This one. So what's your limiting reactant?
1.
No, what's your limiting reactant?
Aluminum chloride.
Aluminum chlorate
Chlorate.
is your limiting reactant. Identify it. Finish the problem. Taking the moles times formula mass over 1 mole, giving you your answer. Everything you have been doing, you're just going to continue doing. You just have to do it twice. Questions? Wonderful, ladies and gentlemen. Wonderful, wonderful, wonderful.
Yeah, put me on. The only thing you put me on was that $20 you might give me.
Quit leaving early.
No, the only thing you put me
Cynthia
on.
would
You-
never leave you early.
You
if
left
you had
the
to.
room. You left early. What part of the sentence do you not understand?
Oh my god, write me up.
But like Cynthia would never leave you early. Like why would Cynthia?
She
wanna
would
leave
rather
this
ditch
class?
Why would
my
I want
class.
to run out of this room and never come
You want
back?
Cynthia to teach the class?
Do you want Cynthia to teach the class?
You should let me teach the
Sorry, I
class.
say she.
Let me teach.
Sure. When do you want to?
I'll
Tomorrow.
become a teacher.
Okay.
Okay, bet.
Goodbye.
Y'all gonna call me Miss Pereira.
You already know I had to put my golf.